So now that we've learned about the trapezoid rule, let's compare the somewhat familiar midpoint rule and this newer trapezoid rule. We'll start with a picture. Interesting observation to make. The first picture here in green is a trapezoid approximation of the area under a curve, and it's just T1. It's just a single trapezoid trying to estimate this area. Okay. The second picture is what the midpoint rule would look like, what this rectangle would look like. And then there's this cool observation they make. If I shave off this much of a triangle, again starting from the midpoint and then shaving it down here, and redraw that exact same triangle here, I'm actually kind of cutting off one piece of the area and moving it over. I'm rearranging it. Okay, so that results in this picture here. It's just a different way of thinking of the midpoint rule. Okay. So keep this picture in mind. We're going to superimpose these three pictures on top of each other, and we're going to try to see what that says about the error of each type of approximation. Here's that superposition I was just talking about. You'll see in red, we're seeing the error from the trapezoid rule, so that's over here. In light red, sorry, it's almost the same color, that's this part here and this part here, that's the error we would get from the midpoint rule. Interesting thing to notice is that the trapezoid rule in this case is overestimating while the midpoint rule is underestimating. Because this is a concave up function, that's why it's turning out that way. If we happened to have a concave down function, the reverse would be true. The midpoint would be overestimating and the trapezoid rule would be underestimating. Oops. There we go. Here's an example with the function f of x equals 1 minus x squared. Thinking about the integral of it, that's a pretty straightforward integral to calculate. Its exact value is 2/3, which we're writing as 0.6 with a bar over it. They're showing you the calculations of T4, M4, T8, and M8. Okay. What you observe about the error is there seems to be a relationship. As I was saying, T4 and T8 are negative here. M4 and M8 are positive here. So the T and the M have opposite sign, but not just that. Notice, for example, on T8 I have 0.0026 something something, and here I have 0.0013. So it looks like the midpoint is not only the opposite sign, but it looks like it's about half the error size. And we're going to wrap this part up by talking about how we can combine those two rules to get an even better rule. And we'll talk about that next. So what you notice, again, the observation we had is that the error for midpoint rule is approximately the opposite sign of half of the error for trapezoid rule. Okay, and we have that in general. We saw it for n equals 4 and n equals 8. It's true in general. Roughly speaking, of course, because we have these squiggly equal signs.